Peace out, Melo. Today discussion topic is BJT, bipolar junction transistor. Bipolar junction transistor. First two, point contact transistor, first transistor ever made. The first transistor was a point contact transistors. The first point contact transistors, John Borden, Walton Benton, and William Shapley, Will Laboratories Mills in 1947. This diagram is showing two point contact transistors. This is one basic, this one is base, this one is collector, this one is emitter, this is the point contact transistors. Next is, what is transistor? A transistor is a three-terminal electronic device made of semiconductor material. Transistor have many uses, including amplification, switching, voltage regulator, and the modulation of signal. Uses of transistor is including amplification, switching, voltage regulator, and modulation of signal. This session will help to you understand the evaluation of transistor, importance of transistor. Third one is definition and transistor types. Fourth one, transistor symbol and operation. Fifth one, advantages of transistor. Sixth one, latest transistor technology. First of all, history of transistor. In 1906, an American inventor and physicist, Lee De Forest, made the vacuum tube tried and anodes, as he called it, used in earlier computer. Interesting stories. This picture is showing picture showing the workbench on John Borden, Stoker professor at OU, and Walton Borden at Bell Laboratories. They were supposed to be doing fundamental research about crystal surface. The experimentally result and being very good through, and there is rumors that there was William Shockley came near to conclude this project, but in 1947 worked alone. Their switches to using thermodynamically pure materials. It is downloaded on it. They could build their circuit in the fixture It was a working application. Jan and Welter submit a point for first working point contact transistors. 1960s, all important computers are using transistor for logical and formative cores for memories. Shockley was 4 years and took their work and invented the junction transistor and submitted a point for the 9 days later. The three shared the Nobel Prize in 1955. Borden continues in research. How do you do first point contact transistors? Works. Schematic for the first point transistors. This one is emitter. This one is emitter. This one is collector. This one is base. Using a semiconductor is gallium arsenide. Gallium arsenides. This is the first point contact transistor work. Quality basic operation of the point contact transistor. A gold foil was golded to a triangular insulating wedges. A narrow gap was cutting with a razor blade to from the E and C. The gap was extremely 50 micrometer wedge. Under forward base EB junctions, minority carriers and inject into base. In case of point contact transistor, strong forward base and required to mostly minorities carriers are corrected by the reverse bias BC junction. Thus the base control the current flow in between E and C. Problems with the first transistors. The point contact transistors is a surface effect device. It is important effect occur in the semiconductor surface. Surface are easily contaminated. Surface affected device enable machine vibrators. First bipolar junction transistor. We are discussing first bipolar junction transistor. We shankly inverted the PN junction transistor. The physically relevant reason in moving to the block of the material. The first junction transistor. First transistor with diffused PN junction will by William Shockley, Bell Laboratories, Murray High, New Jersey, 1949. This is the basic diagram of the bipolar junction transistor. First bipolar junction transistor. Where is the N type of semiconductor? This is germanium single crystals. This is emitter and collector and P type semiconductor, N type semiconductor and P type semiconductor. With the two types of P semiconductor and sandwiched by the one of the N type semiconductor. Morris laws. It is an observation made by the Gordon E. Morris in which the predict the number of the transistors inside an integrated circuit could be doubled every 24 months. At the density, there also minimize the cost of transistors. Transistor definitions. Transistor and a electrical device made of the three layer of semiconductor material that can act as a insulating and a conductor that can act as an insulating and a conductor. The three layers transistor is also known as bipolar junction transistor. Bipolar junction transistor. This is the symbol, basic symbol of the BJT, bipolar junction transistors. Emitter base collector, PNP transistor, when the two types of P-type material and is sandwiched by the one N-type material, where two N-type material sandwiched by the one P-type material. There is two types of BJTs, bipolar junction transistor. First one is PNP transistor and second one is NPN transistor. Look shot of the like two diodes back to back. This is the PNP transistors. First one is the PNP transistor. Second one is NPN transistors. The basic circuits of the NPN transistors. Current IE, emitter current, voltage between emitter and collector VBC, when forward firing IC, and base current IB. At the same NPN transistors, that is, there is the emitter reverse bias in the emitter current, voltage between emitter and collector, that is VCB minus to plus, collector current IC, and base current IB. BJT basic configurations. Bipolar junction transistor basic configurations, that is, in the P-type material there is two P-type materials and sandwiched by the one N-type material. They made by the PNP bipolar junction transistors, and two N-type materials sandwiched by the one P-type material. They made in NPN bipolar junction transistors. There is the middle part of the NPN transistors, thus called is base. Upper part of the PNP transistor collector. Lower part of the PNP transistor is emitter. At the same time, NPN bipolar junction transistors, middle part of the P-type material is called as base. Upper part of N-type material is called a current collector, and lower part of the emitter is called emitter. Lower part of the N-type semiconductor is called as emitters. This is the configuration of the PNP and ENPN transistors. Circuit symbol of the transistors. There is bipolar junction transistors. In terms of bipolar, refer to the use of both holes and electrons as charge carriers in the transistor structures. There are two types of BJTs, the NPN and PNP. The NPN and PNP. Origin of the names. The emitter emits the electron which passing through the device. The collector collect the origin once the negative passed through the base, and the base is and the base. Transistor operations. Base, emitter and collector. Force is minus voltage by current, water flow, current and amplifications. Next, architecture of the BJTs. The bipolar junction transistors BJT is constructed with the dipole doped semiconductors regions separated by the two PN junctions. The region is called emitter, base and collectors. The region of the emitter, base, collectors. Basic constructions of the BJTs: collector, base, emitter. Collector, base, emitter. The same of the NPN and PN. NPN and PN. Architecture of the BJTs. There are two types of BJTs, the NPN and PNP. The two junctions are termed the base emitter junction and base collector junction. The terms of bipolar refer to use of the both holes and electrons as charge carriers in the transistor structures. In order for the transistor to operate properly, the two junctions must have the current DC dash to voltage. The base emitter BE junction is forward bias, so greater than 0.7 volts for the silicon, 0.03 voltage in the germanium. The base collector junctions is reverse base. The reason for the transistors. A transistor has three regions normally: emitter heavily doped, base lightly doped, collector moderately doped. Single crystal of germaniums, there is the structures of the NPN transistors, PNP transistors. Emitter, base, collector, where the n-type material is called base, upper p-type material is called emitter, and lower p-type material is called collector. Transistor symbol, transistors symbols. First is NPN transistors. NPN. This next second one is PNP transistors. They show in figures. First one is NPN transistors. Second one is PNP transistors. Common base in NPN transistors. Common base in NPN transistor in the basic logical circuits. NPN transistor IE, IC, VCE and VBE and VCB, and RS and RL, load resistance, VBB and VCC. Common emitter NPE. This is a emitter is commonly grounded, and ICIB is freely. This configuration is called common emitter configurations. This one is common collector configurations. Transistor biasing. The base emitter junction forward bias. The base collector junction is reverse bias. There is output current can tagged with the large and small. Operating region of the BJT, cutoff region, linear regions, saturation region. Type of transistors: BJT bipolar junction transistor, UJT unipolar junction transistors, FETO field effective transistors, MOS metal oxide transistors. Basic circuit of the BJT: base, emitter, collectors. This is the basic circuit of the BJT bipolar junction transistors. Operation of the BJTs. BJT will operate in the following four regions: cutoff regions for digital circuit, saturation region for digital circuit, linear activate region to be continue be amplifier, breakdown region always distorts. This is the uh, current graph showing voltage versus current. Voltage versus current in basic operation of BJTs. DC analysis of BJC. Transistor current IE is equal to IC plus IB. Their alpha DC, the IC is equal to alpha DC into IB, and beta DC is equal to IC beta DC into IB, where beta CC typical have the value between 20 to 200. DC's analysis of BJTs. DC voltage for the based on transistors. Collector voltage VC is equal to VCC minus IC into RC. Basic voltage VB is equal to VE plus VBB. For silicon transistors, VB is equal to 0.7 volts. For germanium transistors, VBE is equal to 0.3 volts. Q point. The basic current IB is established by the base bias. The point at the which the base current curve intercept the loaded line is the consequences of Q point at the current. This is the showing of the Q point of the bipolar junctions transistors, voltage versus current showing diagrams, the base current IP showing Q points. DC analysis of BJT. The voltage dividers biasing is widely used. Input resistance is RIN is equal to beta DC into RE. The base bias voltage is approximately VB VCC R2 by R1 plus R2. This is the basic structures of the analyzing of DC BJTs. BJT and as an amplifier, class A amplifier, and second one is a class B amplifier. Class A amplifier, BJT class A amplifier. In a class A amplifier, the transistor conducts for the full cycle of the input signal 360 degrees used in low power amplifiers. The transistor is operated in the active region between saturation of the cutoff. Saturation when be both junction are forward bias. The transistor region cutoff when we IB is equal to 0. The loaded line is drawing on the collector curve between saturation and cutoff. It is the basic diagram of the BJT class A amplifier. BJT class A amplifier, 3 biasing made of the class A amplifier: common emitter amplifier, common collector amplifier, common base amplifier. Next, second one is class B amplifier. When a amplifier is based such that it's operating in the linear regions for 180 degrees of the input cycle and is in cutoff for the 180, it's a basic of B amplifier. A class B amplifier is more efficient as a class A. In order to get a linear representation of the input waveforms, the class B amplifier is configured in the push-pull arrangement. The transistor in class B amplifier must be based on this cutoff of the emitted constituency designs. When used in electric switches, a transistor normally on operating alternately in cutoff and saturation. A transistor in cutoff when is the base emitter junction in not forward bias VCE is approximately equal to VCC. When base emitter junction forward bias, there is enough base current is to produce maximum collector current. The transistor is saturated. The basis BJT switches. This is the information of the transistors.